Okay, it's March 20th. This video is showing you what to do for concept number 3 on inscribed angles, which is our title here at the top, found in chapter 9, section 4. Again, this is going to be a little bit of a review, hopefully, of what we've already discussed at the start of this trimester. But I'm going to go through half of these problems. There's 13 on this page. And so I'll go through 6 of them. It's not quite half. But this the first theorem that I want to draw your attention to is found right here. This is on page 669 in your textbook, but theorem 9.6 about inscribed angles. Inscribed angles are the angles that start on the circle, so that's where the vertex is located, and its endpoints are intercepting the arc around the circle as well. But the key thing here is the relationship between this angle here, the inscribed angle, and then also the arc measure, this intercepted arc. So here in the theorem it says, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So the relationship between this angle and then this arc measure, this angle is always going to be half of this arc measure. So for number 1, because they tell us that the arc this inscribed angle is 44 degrees, and they're asking for the measurement of arc AB. Remember that sign up here, A to B, that is this measurement right here in degrees. And because of that this is an inscribed angle, this arc measure is going to be twice as big as that 44. So arc AB is going to end up being 88 degrees. Okay, so not a lot of work shown right there. Moving on to number 3. Number 3, notice that it almost looks exactly like number 1, right? They give us that inscribed angle at 26, so we could say, oh, J to L is 52 degrees. Excellent, that's exactly right. However, they don't ask for us to measure the arc measurement from J to K, or from J to L. They ask for J to K. J to K is this measurement over here. Well, I know this one's 52 degrees, but how does that help me figure out what J to K is? So I gotta reassess the situation. I'm noticing though that LK is a diameter of the circle. Diameters cut the circle in half. Yes, but it also cuts the arc measurement in half as well. So from L to K this way would be 180 degrees. As well, from LJ to K would be 180 degrees as well. So because that portion from J to K and from J to L have to add up to 180 degrees, I would subtract 52 from 180, and I'd get my measurement of 128 degrees. Just like that. Alright, moving on, going down. Let's see which ones we should do. Let's do number 5 and 8. Let's do 5 and 8. Look at these different pictures. Alright, so number 5, it's asking for the measurement of angle W right down here. And notice I've got these lines going all around the circle, making some intersections, making a kind of cool design. I'm going to be looking at our next theorem, which is going to be theorem 9.7. Let's see if I can get that to look at that right there. So this is on page 670. If two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. Okay, noticing here we've got some angles over here, and here this angle in red, the angle in blue. They both are told to be congruent, and that is because not of where they start, because they both start on the circle, but it's where they actually end. They both end at points A and D on this circle. And so the arc measure that they both are intercepting is from from A to D. So they're going to end up being congruent to each other. So let's see how that helps us out on our question for number 5. So for number 5, I could say that angle Z and angle Y, that they would be congruent to each other. So I could set these two expressions equal to each other because they go to the same place, they go to W and X. But I'm actually looking for angle W. Now angle W and angle X, though, would also be the same measurement. So I actually don't have to do any calculations because these two angles are congruent to each other. So since this one's 22 degrees, that's what makes this one 22 degrees. So no work shown there. Let's go over to number 8. Number 8 is asking for angle D. Angle D is located right here, and I'm assuming that this expression right here is measuring my angle D here. In this case, angle D and angle C would be congruent angles, and so I could set 3y plus 8 equal to 5y minus 14 since they are congruent. So that's exactly what I'm going to do out to the side. I'm going to do 3y plus 8 is equal to 5y minus 14. We're going to solve for y, subtract 3y from both sides, and we get 8 equals 2y minus 14. And then I'm going to add 14 to both sides, and we get 22 equals 2y, and divide by 2. And so we get y equals 11. Awesome. But we're not done, right? Because they didn't ask us to solve for y. They asked us to solve for angle D. So I have to plug in 11 into my y, into this expression right here for y. So I'm going to put in 3 times 11 plus 8. 3 times 11 is 33, plus 8 is 41 degrees. So there we are, number 8. So that is our third problem, or our fourth problem. We'll go down to number 9. Number 9 is asking for the measurement of angle A. Angle A is here expressed as an expression, 3x plus 6. Looks like an inscribed angle. Let's see what the book has to say about these problems. This is referencing theorem 9.8, where we have an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So this is still really similar to the first theorem that we did in this video. This angle G is still a inscribed angle, but it's a little bit different because it's intercepting at points that are part of the diameter. So because this intercepts at the diameter, cutting the circle off in half, that angle G is going to be a right angle. It's half of 180. So that's going to help us out with these questions. So we have angle A. This angle, it is not intercepting a diameter, but angle B is. So angle B, I can say that angle B is a right angle. So 90 degrees, don't need to do any of those other calculations, only because A to C is a diameter, it is going through the center. Bingo. Well, what else do I know about these two angles then? I got to solve for A, but the only angle I know for sure right now is that angle B is a right angle. Well, we still use our information about triangles that all the angles inside of a triangle add up to be 180 degrees. And since I already know this one's 90, that means these two angles have to also add up to 90 degrees. Because that's all I have left over. So I'm going to set 3y plus 6, and I'm also going to add to it x. So I've got this angle, x, that's represented here. I've got this angle, 3x plus 6, oh, 3x plus 6, sorry, not 3y. Can't add y's and x's together. So I'm going to add these all together, and I can set this equal to 90 because these two have to equal 90 degrees. So I'm going to add those together, and my like terms added together, I get 4x plus 6 equals 90. I'm going to subtract 6 from both sides. I get 4x equals 84, and divide by 4. And 84 divided by 4 comes out to being 21. Okay, and again, I did all that, and I end up getting x equals 21, but x is not the question here. It's asking for a, so I've got to plug in 21 in for x here, and I would get 3, and instead of putting x, I'm going to put 21, plug that in, plus 6, and 3 times 21 gives me 63, plus 6 gives me 69. So angle A is going to be 69 degrees. Awesome. Okay, and the last one I'm going to help you out with is number 12 over here. Notice with this one, it's still similar. This is a quadrilateral that has been that's inscribed inside this circle, and it has its own properties. Notice that here we have an inscribed angle, and it's intercepting this arc from HEF. But then also this angle E over here, where it intercepts, it is intercepting the other portion of the circle that angle G was not. So opposite angles on a quadrilateral will always add up to be 180 degrees. They are going to be supplementary to each other. Same thing with H and F. They do the same thing. H and F will also be supplementary. So we've learned that before, that quadrilaterals, the interior angles of a quadrilateral always have to add up to 360, and that's what this last theorem shows in theorem 9.9. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Da, da, da. So that's the theorem that we're going to need for this one. So for number 12, it's asking for the measurement of angle H. Angle H and angle F are those opposite angles. So these two are supplementary. So I can add 6y minus 4. And it's careful, that doesn't mean that they're congruent to each other. Supplementary means that they add up to 180 degrees. So I'm going to add them together. 5y minus 3, and set it equal to 180 degrees. Combine my like terms, I get 11y minus 4 minus 3 makes minus 7. Okay, and I'm going to add 7 to both sides. I get 11y equals 187, and divide by 11. And 187 divided by 11 comes out to being, is that 17? 87 divided by 11. 17. Y equals 17. And one more time, it's not y that I'm solving for, it is angle H. So angle H is 6 times y, so I'm going to do 6 times 17 minus 4. So 6 times 17, that's 64, 102. 6 times 17 is 102 minus 4. So we got 98 for angle H. Okay, and the last problem down here, a probability question. I'm going to have you try that on your own, see if you can make sense of it, and email me any questions if you have any.